Okay, hi guys. So today we're looking at energy change calculations. And over here what we have is a reaction between hydrogen peroxide, and actually this is decomposed and broken down into water and oxygen. And you can see that this is a decomposition reaction. Now, what is hydrogen peroxide? It says in the question, it's often used in bleach or to lighten hair. Hydrogen peroxide slowly decomposes, and here's the important part. So you know that on the left hand side you've only got one reactant. On the right hand side you produce water, which is one product, and here is the other product, oxygen. Water and oxygen. So then you have to calculate the bond energy calculations, and so you need to know the formula for this, which is the energy change. All right, so energy change is always going to be the reactants take away the products. And if you've done work on exothermic endothermic reactions, you would also know that when you have a reactant and you have to break the bonds, the first part you have to do is to break all of these bonds, and then you form and rearrange those atoms to form new bonds, i.e. water and oxygen. So reactants also can be bond breaking, which I've basically put for short BB, and the products that are made are bond making. So new products are made and therefore new bonds are made. So this is bond making. And you might see this in an exam, and you need to remember the order of which you do these calculations. So what do we have here? So we have 2HOOH. So let's just rub this out and let's look at this again. And we can see that we've got to find the bond enthalpies. Now the bond enthalpy are all here. So the bond energies are all here. Okay, we've got the HO bond. So for the HO bond to break, it's 464. For the OO single OO bond, it's 146. And for the O double bond O, it's 498. So with that in mind, then let's work out what each of them are, just so that it's clear for you. I'll do the reactants first. So I'll write it out again. So 2H O O H. So what's being broken here? We need to know, because we need to break all of these bonds. And clearly here you can see that there is a bond broken over here, a bond broken here, and a bond broken here. Now the HO bond and the HO bond over here are the same thing. Hopefully you can see that, because this is HO and OH, which is basically the same, just written the other way around. Okay, so I've just kind of drawn this or shown this bond being broken in blue. And so the HO bond, you know, has a energy of 464. So we've got two of these. Now, the interesting thing here is that there's also a 2 in front. So if I've got 2 at the front, I've literally got to multiply the whole thing by 2. So if I've got 2 bonds broken here, that means I've got 2 times 2 bonds, meaning 4 altogether. Okay, so that means 2 times 2, which tells me, in other words, that there are 4 OH bonds broken. So I can write that as the following. To make it easier and look more nicer, we've got 4 OH bonds being broken. Yeah? How many O single O bonds do we have? Well, we have one O single bond O. So let's write that down. O single bond. And the single bond is, and now be very careful, because the double bond and the single bond look the same, but you can clearly see one has one line and the other has 2 lines. So don't forget that this is 146. So how many do we have of these? Well, we have one over here at the moment, don't we? But there's a 2 in front, So therefore, we're going to times this by 2. So altogether, how many OO bonds do we break? Well, we break 2 OO bonds. So let's just make that look nice and neat. And that becomes 2 OO single bonds. So that side is done. Okay, now let's look at the product side. So I'm just going to scroll down a little bit. And the product side, we've got, I'll just underline it, we've got H2O and we've got O2. So I'll write that again. So 2H2O plus we have our O double bond O this time. So these are for the products. And so let's do that then. So how many bonds are being broken first of all? Forget about this for the time being. We have 2 OH bonds broken. So one broken here, one broken over here. So 2 bonds broken times the 2 over here. That means that we've got 4 altogether. So let's rub that out and let's make it nice and neat. So we have 4 OH bonds broken altogether. This time on the right hand side with this oxygen, well, we don't have any number in front, so we have to assume it's 1 O double bond O that's broken. So only one of these double bonds are broken, and so therefore we can simply write this as the following. So we've got O double bond O, and if you want to write 1 just to make it easier for you, you know that 1 double bond O is broken. And then what you do is you simply plug in the values for the bonds that have been broken. Okay. Now for the bonds that have been made, we'll do the products afterwards. Let's just do the reactants first. So let's go back over here. So these are, remember, these are the reactants. In this case, it's only one reactant that has been decomposed. So 4 times OH is the same as saying 4 times 464. Okay, and 2 times OO is the same as saying 2 times 146, which I've circled over here. Find the total of that, and that should give you 2418. So I'll just do that with the calculator for you guys. This is a really cool website I use. If you don't have a calculator on you, just go to desmos.com and you can just use a scientific calculator on your computer, which is pretty cool. And the answer here is 2148. So that's all good. So altogether, these two together equal 2148. So we've got the total number. Oops, that's not come into picture. Let's maybe move that along over here, make that a bit smaller for you guys. There you go. Now you can see that. The other one then is 4 times OH. So let's do that then. So 4 times 464 plus our O2, which is just one of them. So just 1 times 498. And what does that give me? Let's have a look at that calculation. So the answer for bond making is 2354. You can just confirm that with the calculator, and I got 2354 correct. So now the last thing you do then is you say, okay, well, we've got our bond making and our bond breaking calculations. So remember, it's a reactants take away products. So our reactants, I'll just put it in square, is 2148. And we're going to take that away from our products, and our product answer is 2354. So the overall answer, therefore, is going to be, just put it in the calculator for you so you can see, answer equals minus 206. The answer equals minus 206. Now, if it's a minus number, remember guys, energy is therefore, or more energy is transferred to the surroundings, or heat energy is transferred to the surroundings than taken into the bonds, because bond breaking is less than bond making. So the bonds formed take up more energy or use more energy, so therefore this overall reaction is exothermic, and that is indicated by this negative sign. You know that this reaction is exothermic. Kilojoules